Hello everybody. Today we are going into a marathon about GMAT triangle. Overall, we are going to start from the properties and definitions around the triangle all the way to about 20 plus theorems in this. I am not going to go into a lot of detail. However, for each theorem or property, I will point out some important things and how relevant it is to GMAT. Even though this is a high level kind of a session, it is important that you do not just cruise through it, but get a pen and paper so that you can start taking some notes. On YouTube, I have divided the video into the chapters so that you can skip forward, skip back as you need while you are reviewing it, so that you can keep coming back to this video to look through the different properties. And if you find this video helpful, please do not forget to like and subscribe to my YouTube channel. Your likes help me get recognized across YouTube, and that is very helpful to me. So I hope you will take a moment to like this video if you find this video helpful. One question that I keep getting asked is, why do I need to remember theorems and properties when all of them are pretty derivable? And the simple answer here is time. You can probably solve any question that comes on GMAT without remembering any of the theorems and properties, because you could likely derive them. However, that is not applicable in 100% of the cases. But here is the thing, in GMAT, if you remember a theorem and property, you can solve the question much more quickly than trying to derive the property on the spot. The more you remember the theorems and properties, the better chance you would actually save time on that question, and then you could give that time to a question that is of a higher difficulty level. That is the most important thing about these theorems and properties. Most of them are universally applicable, and if you remember them, you would have a better chance of saving time on the exam and giving it to the question which deserves more of your time. Without further ado, let's start jumping into the triangle. You're all familiar with what a triangle is. However, in terms of nomenclature, there is one important thing that I wanted to bring to your attention, and that is, how are the sides decided? So if I have a triangle A, B, and C, what is the side A? In general, the side is opposite to the vertex. So this is the vertex A. Side A will be opposite to the vertex A. This is the vertex B. Side B will be opposite to vertex B, and so on. And similarly for C. The next important thing to note is, corresponding to each side, there will be a height. So when I draw a perpendicular from the vertex A all the way to side A, which is actually side BC, this is my height corresponding to A. Similarly, this is my height corresponding to C, and so on. When you come to the areas of triangle, we are all familiar with half base multiplied by height as the area of the triangle. What is important to remember is that each side has a height corresponding to itself, as I have denoted in the figure. What that means is the area of the triangle can be written as half HA into side A, which is same as half HB multiplied by side B, which is same as. There is also another formula for triangles, and that is dependent only on the sides, not on the height itself. And that is called Hero's formula, which is root of S multiplied by S minus A multiplied by S minus B multiplied by S minus C. What is S? S is nothing but the perimeter of triangle divided by 2. Now this formula is not generally used or asked in GMAT directly. However, it is relevant because it is important to know that when you know all the sides of the triangle, that is enough to answer the question around area. You don't need to find corresponding heights. If you know all the sides of a triangle, that will yield an area. So you don't always need to know the height. Obviously, this formula is generally too much calculation for GMAT, so it may not be asked directly. So let's start with a thought question, right? We already talked about areas, and here we have two triangles, triangle ABC and triangle ABD. Which of the triangles do you think would have greater area? So this is a classic problem of a triangle between two parallel lines, and very basic application of the area of triangle formula. And it follows from the fact that the distance between the parallel lines is always the same. So this height will be same as this height. The area of triangle ABC would be half AB into height, and the area of triangle ABD would also be half AB, which is the base, multiplied by height, which means that two triangles between parallel lines have the same area as long as they have the same base. If they don't have the same base, then it's a different calculation. You will have to solve it case by case basis. And one of those cases is right here. Here we are given that L is parallel to M, ABDE, so this guy is a parallelogram, which means this side would be equal to this side, and this side would be equal to this side. We are asked if triangle ABC is greater than triangle DEF in terms of area. So ABC is this triangle and DEF is this triangle. I already know that AB is equal to DE, right? Because they are the opposite sides of a parallelogram, so they will be equal. Also, the heights of these two triangles is going to be the distance between line L and M, which will be H. And what we are actually saying is the base is the same because it's the opposite sides of a parallelogram. The height is the same because it's the distance between the two parallel lines. Hence, the area of triangle ABC would actually be equal to area of triangle DEF. GMAT can ask this kind of question in many different ways, some more complex than others. This was just for the demo purposes. So next we are going to talk about some internal angles and external angles of the triangle, and we are going to cover three theorems as a result. Let's first understand what an internal and an external angle is. So in this triangle, these are the internal angles. However, most people do not understand what an external angle is. So in a triangle, this one is not an external angle. This angle could be external or this angle could be external. What that means is when you extend a base outside of the point, the angle it makes with the other side is the external angle. And there are two external angles possible for each vertex, and that is fine. As you know, angles, the vertically opposite angles are equal. So this angle, for example, would be equal to this angle. And that is important to remember. If you think of external angles as this one, then you could get a lot of questions wrong because that is not a real external angle. In fact, by the theorem, vertically opposite angles are equal. This angle is actually equal to an internal angle. The other important thing is to understand the relationship between the external and internal angles. So let's take this external angle because I've created a lot of mess over here. So for this external angle, this internal angle is the adjacent internal angle, and these two internal angles are the opposite internal angles. For an external angle, there is an adjacent internal angle and there are two opposite internal angles. So let's start with some of the theorems. The first one you already know, that angle A plus angle B plus angle C, sum of the angles in the triangle is equal to 180. What you also know is the sum of the angles on a line is 180. So this external angle and this internal angle, which is the adjacent angle, would be 180 degrees also. And that brings us to our next theorem, which is external angle. So again, this angle is actually equal to sum of these two angles. And similarly, this angle, and I'm going to mark it like this, will be equal to the sum of opposite internal angles. For this, opposite internal angles would be this guy, and so on. And finally, one of the most important theorems of triangles is that the sum of any two sides in a triangle is always greater than the third side. This theorem is used in a lot of data sufficiency questions, can also be used in a lot of problem solving questions. All in all, very, very important theorem. You should always remember it. Lot of applications around this particular theorem. And here is one. So if you want, you can pause here, try to solve this question by yourself. Should not take you more than maybe 1 minute to solve this question. If it is taking more, then you probably are going in a wrong direction. Okay. Among the following answer choices, which one gives a triangle of the largest area? All right. So first of all, it has to be triangle because there are apparently answer choices which are not triangles, and also has to have the largest area. So 6, 2, 3. This is not a triangle. Why? Because the sum of two sides has to be greater than the third side in a triangle. And here, if you see 2 plus 3, which is 5, is less than 6. So it is less than the third side. So this is not a triangle. Similarly, 5 plus 3, 8 is less than 10. This is not a triangle. 4, 6, 8, possibly a triangle. 662, possibly a triangle. 494, 4 plus 4 is 8, which is less than 9. The sum of two sides is less than the third side, which is not possible in a triangle, not a triangle. So I have boiled my situation down to these two. Now, remember Hero's formula? You can revert back and actually go and check it. Hero's formula says that my area is equal to root of, it's a long formula, but we can apply it very, very quickly. S is half of the perimeter. For 468, the perimeter is, the Hero's formula then looks like 9 multiplied by 9 minus 4, 5, multiplied by 9 minus 6, 3, multiplied by 9 minus 8, which is 1. Similarly, this looks like 7 multiplied by 7 minus 6, which is 1, multiplied by 7 minus 6, which is 1, multiplied by 7 minus 2, which is 5. As you can obviously see without any more calculation, this area will be larger than this area. So the answer to this question would be choice number C. Classification of triangles. So there are many ways to classify a triangle. One of them is based on the angles in a triangle. So a quick definition, any angle 90 degree is called a right angle, less than 90 degree is called an acute angle, and greater than 90 degree is called a obtuse angle. In an acute angle triangle, all the angles are less than 90 degree. Equilateral triangle, for example, which has all the angles as 60, is an example of that. In a right angle triangle, you have exactly one angle as 90 degrees, and the other two would be less than 90 degrees, which means they will be acute angles. Since the sum of the angles in a triangle has to be 180, you cannot have more than one angles as 90 degrees in a triangle, right? And an obtuse angle triangle is a triangle in which one angle is more than 90 degrees. The other two angles have to be less than 90 degrees. And acute, because you cannot have more than one angles in a triangle as more than 90 degrees, otherwise the sum of the angles would be beyond 180. The other way to classify a triangle is through sides. A triangle where all three sides are unequal is called a scalene triangle. A triangle where two sides are equal is called an isosceles triangle, and a triangle where all sides are equal is called equilateral triangle. The other property of an equilateral triangle is that all angles would be 60 degrees. In fact, an equilateral triangle is a special case of isosceles triangle, and this is an important property that you would have to remember, that an equilateral triangle is a special case of isosceles triangle. In fact, it is an isosceles triangle with any one angle as 60 degrees. If you want, take a pen and paper to try to solve this and reason it out. If you're not able to derive that, let me know. I'll create a small video to explain it. Let's keep moving. Now, this is a very important, however, not very often discussed in any of the GMAT books kind of area, which is the centers in a triangle. And what that is there are four kinds of lines in a triangle. A median, which divides the opposite line into two equal parts. Altitude, which is the perpendicular from the vertex to the base. Angle bisectors are the lines which bisect the angle of the triangle, and there is perpendicular bisectors, which are different from altitudes because they are drawn from the middle of the line all the way up, and they may or may not connect with the opposite vertex. All of these four lines have very, very important properties, and the most important thing about them is when you draw these lines out in a triangle, they always meet at a certain point. And each of these points has a different name. The median is the line that joins the vertex to the midpoint of the opposite line. When you draw the three medians, they meet at a point, and that point is called a centroid. When you draw the altitudes of a triangle, which is nothing but perpendiculars from the vertices to the opposite line or the base, these also meet at a point, and that point could be internal or external to the triangle depending on the triangle, and that point is called an orthocenter. The angle bisectors, these are the lines that bisect the angles of a triangle, also meet at a point, and this point is called an incenter. And in fact, with the incenter, you can draw a circle that is tangent to all the lines in the triangle. This is a very important property that you could utilize in a lot of GMAT triangle questions. And finally, when you draw perpendicular bisectors, which are lines perpendicular to each side of the triangle but also bisecting it, they also connect at one point, and that point is called the circumcenter of the triangle. And you can actually draw a circle that circumscribes the triangle, which means each point of the triangle would lie on that circle, and hence that circle is called the circumcircle of the triangle. This is also a very important concept and may help you solve a lot of GMAT questions where triangles and circles are involved. Okay, so here are some additional properties that you may or may not want to remember because these are generally quickly derivable, so it is not important that you remember all of them. Again, it's about time saving, so if you remember them, it would be helpful. So property 1 is that if you have an isosceles triangle with one of the equal angles as 45, then it will automatically be a right angle triangle. But remember, it has to be one of the equal angles, not the unequal angle. Otherwise, you get a different triangle. An isosceles triangle with any one angle as 60 degrees is always an equilateral triangle. In an isosceles triangle, the perpendicular from the apex, which is the non-equal angle, always bisects the base, and you can again very easily derive that property, but it is always good to remember it. And finally, if you have an equilateral triangle, then all the four centers which we talked about, the centroid, the orthocenter, the circumcenter, and the incenter, all fall on the same point, and that is because the symmetry of the equilateral triangle. One additional tip about these: they will all fall on the same point and they will all be inside the triangle. If you recall, we saw some cases where the orthocenter and the circumcenter were outside of the triangle. However, for an equilateral triangle, all of them would be the same point and would fall inside the triangle. I have given an exercise here which I would like you to attempt and leave a comment on what you think is the answer to this question is. Leave a comment with what you find the area is, and I personally respond to all the comments, so I will respond whether the answer is correct or not. Moving on to right angle triangles. These are some of the most important concepts and questions that you will be asked in GMAT. You already know Pythagoras theorem that the base square plus height square is equal to hypotenuse square, or base square plus perpendicular square is equal to hypotenuse square. What I really want to emphasize here, even though trigonometry is not in the scope of GMAT, however, there are Pythagorean ratios that I think you should remember. Also, some of the Pythagorean triplets, and I have highlighted about 6 of them, that it would be good if you remember them so that you can easily point them out in a question rather than spending time in deriving them and confirming them. Pythagorean triplets are integral solutions to Pythagoras theorem. For example, some of the most famous ones are the triangle with 3, 4, and 5 as hypotenuse, triangle with 5, 12, and 13 as hypotenuse. However, while solving practice problems for GMAT, you might see some of the other ones as well. Pythagorean ratios are for right triangles that have certain angle measures like 30, 60, 90, or 60, 30, 90, or 45, 45, 90, and a ratio or relationship between base, perpendicular, and hypotenuse. Here is an example. Let's assume you are given a right angle triangle with one angle is 60 degrees and the other is 30, and the hypotenuse is 12. Is there a way to find the base and the perpendicular? The answer is yes. Using trigonometry, it is very, very straightforward to find that. However, using Pythagorean ratios, and Pythagorean ratios are part of the GMAT scope, using Pythagorean ratios, you can easily first identify which kind of triangle it is. So I have a 30-degree angle corresponding to the base, so it was this triangle, and when this is applied, base is nothing but √3/2 multiplied by the hypotenuse, which means that the base will be 6√3. Similarly, we can quickly find the perpendicular. So I highly recommend that you remember these Pythagorean ratios. If you write them down a couple of times, then it is easy. And when you're trying to solve the problems, there are 2 steps. 1, identify which Pythagorean triangle does the question fall under? So 30-60-90 or 60-30-90 versus 45-45-90. And second, just apply the ratios to get corresponding heights, bases, or hypotenuse depending on what is given in the question. So from here we jump on to another set of theorems about how the sides are related to angles within the triangle. If you recall, we talked about how the side opposite to angle A is the side A. So the first theorem is that angles opposite to equal sides are equal. So in an isosceles triangle, for example, these are the two equal sides. Then what the theorem states is the angles opposite to equal sides are going to be equal. So this angle, for example, is opposite to this side, and this angle is opposite to this side, and these two angles would be equal. Then we move a little bit beyond the equality to the inequalities, and the first theorem states that angle opposite to greater side is greater. So in this triangle, you can obviously see that side A is greater than side C. What that means is that angle A is going to be greater than angle C based on theorem number 7. So let me just write it here. Now the reverse of that is also true. So what that means is if I'm given that angle A is greater than angle C, then side A will be greater than side C. Now these may be small theorems that you may or may not have heard of. However, they are extremely important theorems to remember because the application of these theorems applies to a lot of geometry problems, whether you're looking at a problems that combine triangle and circles together, triangle parallelogram together, having a way to figure out the relations between two sides or two angles in a triangle is gold. So remember these theorems, take a moment to look at them, understand them, and put them in your memory box, because if you don't, then you are likely going to struggle with a lot of geometry questions. Theorem number 9 states that a triangle in a semicircle is a right angle. If you draw a circle with the diameter as one of the sides, then when you draw the triangle out, doesn't matter where the third side is, it will always be a 90 degrees. It's a very common circle theorem as well, so you would probably see it in my circle review. And while it is a common theorem, it is also an important theorem to remember, because a lot of questions which kind of combine triangle and circle concepts have an application of this theorem. And finally, from this we derive theorem number 10, that for a right angle triangle, so let's just take this ABC triangle, the circumcenter, and if you recall, the circumcenter was the perpendicular bisectors. And for a right angle triangle, the circumcenter, which creates the circumcircle, has to lie on the diameter of the circle or the midpoint of the hypotenuse, because as you can see, this actually is the circumcircle, and this, which is the midpoint of the hypotenuse, is the center of the circle as well. Again, an easily derivable theorem or property. However, remembering it will save you those extra seconds. Okay, so this is one of those theorems which are very rare in application. However, if you don't know these theorems, it will likely cost you the question itself. So there is a trade-off. You may actually not commit to the memory, assuming that it will not come in the exam. However, if it does come in the exam, you would likely not be able to actually proceed and get the answer. And the theorem is this: when you have an angle bisector divides an angle into two equal parts. So for here, PS is the angle bisector, and I have these two angles are equal. So it is dividing the angle P into two equal parts, divides the opposite side in the ratio of the two sides. So what that means is PQ divided by PR equals QS divided by SR. Two things are important here. One is that the division into the ratio, and also the order. As you can see, PQ and QS are on the top and PR and SR are at the bottom. The lines that originate from the same vertex are on the same place, whether up or down. This is important because if you flip the ratio, you will get a wrong answer. You can write the ratio of opposite way also. So PR divided by PQ equals SR divided by SQ. Now in this case, Q is always at the bottom in the denominator and R is always at the top. So this is important. If you mix and match, then you will have a problem because the ratio will be incorrect. And the next theorem is another one of those theorems which are extremely rare. And if you don't get it, it is absolutely fine. You can just skip over this. However, again, if there is an application of this theorem, it might actually cost you the question itself because you would not know how to proceed. This is a very, very convoluted relationship and a very complex proof of the theorem. You will not have enough time to actually derive this theorem in the exam. And here is what it says. In a triangle, when you draw the median, so AD, this is the median of the triangle. The sum of the squares of the two sides which are not involved in the median drawing. So here it's like side B and side C. So B square plus C square equals to 2 times A by 2 square plus the median square. Now I realize this is very, very complicated. It was important for me, for the sake of completeness, to include this theorem. If you don't remember this theorem, it is absolutely fine. If there is one thing I would like you to remember, is that there is a relationship between these two sides, the opposite side and the median. So in a data sufficiency question, for example, if you're given the 3 sides, you are likely going to be able to figure out the median from one side to the other side because of this relationship. And that, I think, is the important takeaway. For another obvious takeaway is that if you know the median and any two sides of the triangle, then through Apollonius's theorem, you can actually find third side. So for data sufficiency questions, just knowing that there is a property that relates the median with the 3 sides of the triangle will actually help you solve the data sufficiency without actually applying the theorem, because you would know when the data will become sufficient. All right, so now we're going to jump into a slightly more complex area, which is the congruent triangles and the similar triangles. Now, these are very, very important concepts. From the practice questions, we know that this is an often applied area for some of the geometry questions. So let's first understand what is congruency. The term sounds complex, but what it means is two triangles are congruent when they are exact size and shape. You can call them replica of each other or duplicate of each other. So think of any two shapes who are replica of each other, then you call those shapes as congruent. What that means is, for those shapes, and especially triangles, all the sides are going to be equal and all the angles are going to be equal because they are exact replica of each other, or they are duplicate of each other. All right. So in triangles, there are ways when you are given a little bit of the information and you can derive that the triangles are actually congruent. And once you know that they are congruent triangles, then you can find any unknown angles or sides of those triangles. So the first one is SSS. What that means is if 3 sides of 2 triangles are equal. So in this case, I have 2 triangles and I have marked the corresponding sides as equal. So this side is equal to this side is equal to this side, and this side is equal to this side. This is important to mark it this way so that you can clearly see which side is equal to what side. And what the theorem states is that if you have 2 triangles who have 3 corresponding equal sides, then those triangles have to be congruent. The proof of it is not as important as the theorem itself. What that means is, since these 2 triangles are congruent, it also means their area would be equal, their perimeter would be equal, and all the corresponding angles would be equal, which means this angle would be equal to this angle would be equal to this angle, and this angle would be equal to this angle. Just note how I am marking the corresponding equal angles or sides. For example, I am marking 1 dash for the corresponding equal, these 2 corresponding equal sides, 2 dashes for these 2. This is an important nomenclature that I recommend that you follow so that you know what are the corresponding equalities amongst 2 triangles. Because right now what I have shown are 2 triangles which kind of have the same base and the same orientation. However, in the exam, you could have one triangle like this, other one like this, and as you can see, it's the same size and shape, but if you don't mark the corresponding equal sides properly, then you could actually make mistakes around the corresponding angles and things like that. The second theorem on the congruent triangles, which is our theorem number 14, is side angle side. And what that means is, if I am given that 2 corresponding sides of triangles are equal, and the angle within those sides is equal, then the triangles have to be congruent. which means they will be duplicate of each other. So this side is equal to this side and this side is equal to this side, and not any angle but the angle included within those sides is equal, then the triangles are congruent. And the next theorem is very similar, but it's angle side angle, where we have two corresponding angles equal and the included side also equal. Those are congruent. And finally, you have the angle side, where even if you don't get an included side but an excluded side which is not within those two angles equal, then the angles are congruent. Note that you don't have a side angle, which means not included angle, as a property. You have SAS, but you have ASA and AAS. Okay, so this is important to note. Don't make the mistake of assuming that SSA, which means an angle outside of those two sides, is a congruency condition. It is not. And finally, RHS is also a congruency condition which is applicable to right angled triangle. And what that says is if a hypotenuse and any side of the triangle are equal, then it is automatically congruent. This is actually derivable from theorem 15 and 16, so it is not that important of a theorem. However, if you know it, it will actually save you some precious few seconds. So a quick note here, congruent triangles are extremely important concepts in GMAT or any geometry, and understanding all of these theorems and remembering them is going to be very, very important. Make sure you remember these theorems, write them down multiple times, and make sure you understand which theorems are applicable. We have talked about side, we have talked about side, we have talked about angle, side, angle, side. But how about angles? So if I'm given that there are three angles in a triangle equal, would it be a congruent, right? That's a question that automatically comes into mind. Why is that not a congruency condition? Three angles are equal, right? And A is not a congruency condition. So don't get into a trap if you see three angles equal, assuming those triangles are going to be congruent or duplicate of each other. They will not be. They are similar in shape, but they may not be equal in all aspects. They are similar in shape, their sizes are proportional, but they may not be exactly duplicate. And here are the two examples. As you can see, the angles are equal, but one triangle is actually bigger than the other triangle. So their areas and perimeters and sides are all going to be proportional in some way, and we'll talk about similar triangles. However, they will not be congruent. So AAA is not a congruency condition. If you have any questions, please leave in the comments below. I know this is a lot and I'm going at a decent pace, so please feel free to ask questions. Next is, of course, similar triangles. They are proportional in size, so they're not necessarily duplicate of each other, which means the congruency conditions may not apply, but similarity conditions may apply, right? And just like congruency conditions, there are similarity conditions, and some of the similarity conditions are same as congruency conditions, but instead of equality, we talk about ratios. Congruent triangles are a very special case of similar triangles where the ratios are actually equal to 1. So in short, similar triangles look alike. They are proportional in size and shape. So they have similar shapes, but the sizes may or may not be equal. Okay. So the first condition, and we just talked about this condition, right? A is a similarity condition, which says that if I have two triangles where corresponding angles are equal, so angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R, then these two triangles are similar. And what does similarity means? Similarity means that the sides will be in equal proportion. So one of the most important things you need to understand in similar triangles is how to write down the similar triangles so that the corresponding vertices align, and then the ratios are very, very easy to kind of calculate from there. However, if you don't write it the right way, you would end up making mistakes. So here, angle A is equal to angle B. So let me start writing it down. A corresponds to P, B corresponds to Q, and C corresponds to R. So what that means is ABC is similar to PQR, not QPR, not RPQ. ABC is similar to PQR, and hence the sides will be in equal ratios. So AB divided by PQ would be equal to BC divided by QR, would be equal to AC divided by PR. If you don't write the triangles in this kind of nomenclature where the corresponding vertices are written down, then you will make an error because you would come up with wrong ratios. So the nomenclature on how to write similar triangles is of utmost importance. Please practice it as much as possible. Okay. The next property of similar triangles is side angle side. Now here again we don't talk about equalities, we talk about ratios. So side AB divided by PQ equals side AC divided by PR, and angle A is given to be equal to angle P. So let me write the corresponding vertices first. Angle A and angle P are equal, right? And then I'm given side AB is same as side PQ. So if I write AB, then I have to write PQ here. And then what it says is based on these properties, and the second thing I'm given is AB divided by PQ is same as AC divided by PR, right? So AB divided by PQ and AC divided by PR are kind of the ratio. So this is how I would write my triangles out, and then I can derive corresponding ratios. Since these triangles are similar from the SAS condition, that would mean that AB by PQ is equal to AC by PR. This was already given to us. Is also equal to BC by QR. And the third property is SSS, which means that if each pair of corresponding sides have the same ratio, so side AB divided by side PQ equals side AC divided by PR equals side BC divided by QR, then the two triangles would be similar. If that ratio is actually 1, then they would be congruent. Now here is why I was kind of insisting you follow certain nomenclature. So if you can see, these are two triangles, triangle ABC and PQR, and ABC is like this and PQR is just kind of tilted version, a slightly bigger version of ABC. However, if you just look at them, you don't see the similarities, and this is where you can trip up while solving a question, because they don't look similar. However, based on the information given, you could be given that AB is equal to PQ. So again, we write out the triangle with whatever is given in terms of corresponding sides, and then find the ratios and apply the ratio to find other information in the question. This is why the nomenclature of single dashes and identifying the corresponding angles. So let's look at this angle, right? Angle A is actually equal to not angle R, it is actually equal to angle P, right? Angle B is between the 1 and 3, right? So these two. So angle B is equal to angle Q. So unless you mark the corresponding vertices properly and follow the nomenclature, you are going to confuse yourself while solving the questions in the exam. So the nomenclature and how you write it down is very, very important in similar triangles. Some of the properties in similar triangles, we have already seen that the corresponding sides have the same ratio. Corresponding angles are equal, which is same as the AAA property. The ratio of the perimeters will be equal to the ratio of the sides, very easily derivable properties. And finally, the ratio of the areas will be square of the ratio of the corresponding. Okay, that brings us to two important theorems which are actually derived from similar triangles. That is why I have placed it after the similar triangles. And this is also one of the most important theorems in triangle, very often applied, although not directly asked about, but very often applied in solving geometry problems. And the theorem 1 is when a line is drawn parallel to one side of the triangle. So here I have shown you PQ, but I could have easily drawn a line like this, right, and made it a little bit more complicated. When a line is drawn parallel to the third side of the triangle, it divides the other two sides in equal ratio. So for this line PQ, which is parallel to BC, AP divided by PB is equal to AQ divided by QC. Very, very important theorem. And the converse of this theorem is also true. So if you draw a line that you may not know is parallel, you draw a line which divides the two sides of a triangle into equal ratios. So I don't know if it is parallel or not, but I'm given that AP by PB equals AQ by QC, then that line has to be parallel to the third side. And again, as you can imagine, given that two lines are parallel, can give so much information in a question about the angles involved, about the distance between the two lines. Depending on the question, it can actually help solving the question. So this is it. This was the triangles review. We covered about 22 theorems and bunch of other properties about triangles. As I said, remembering these theorems is of utmost importance if you want to save time. Some of these theorems are easily derivable in the exam, however, it will cost you time. We also saw a couple of theorems like Apollonius theorem, which is absolutely impossible to derive during the exam, and not knowing it or not understanding it could cost you the question itself because you would not know how to approach and you will be stuck. I hope you like this video. I apologize for not going too deep into each of the theorems, otherwise this video would have been couple of hours long. Each of these theorems would have practice problems and applications, which if you are interested, please let me know and I could dive into some of the practice problems for those theorems that you are actually interested into diving deep into. Thank you for bearing with me. I hope you found this helpful. Please do not forget to press like. All the best with your prep.